Let's talk about solving linear differential equations using power series. This is a cool technique. Find a power series solution, summation n goes from 0 to infinity, c sub n x to the n to the linear differential equation y prime equals 3x squared y. Here's what we do. First, this is only going to work for linear differential equations. So it's some function of x times y plus some function of x times y prime plus some function of x times y double prime, etc. And we have one of those equations in this case. So we're going to set y equal to this power series, summation c sub n x to the n. Then we take the derivative, y prime. That'll be c sub n x to the n minus 1. So now we're just going to plug this in for y, and we'll plug this in for y prime. Plug this in for y prime on the left side. So here's our differential equation we want to solve. If we have y prime equals 3x squared y, then we've got this power series, which was y prime, equals 3x squared times this power series, which is y. And then we just compare coefficients. So let's multiply it out. This is going to be on the left side c0 times 0x to the negative 1 plus c1 times 1x to the 0 plus c2 x to the 1 plus blah, 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 equals 3x squared times c0 x to the 0 plus c1 x to the 1 plus c2 x squared, blah, 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 blah. So when we multiply this out, we get c1 x to the 0 plus 2c2 x to the 1, because again, there's a 0 here, so we're not going to count that. 3c3x squared, 4c4x cubed, blah, 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 equals 3c sub 0x squared plus 3c1x cubed plus 3c2x to the fourth, etc. And that's because this x squared combines with this x to the n. And then we just compare coefficients. So here's what we've got. Compare coefficients. Compare coefficients, for example, of x to the 0. c1 equals, well, there's no x to the 0 here, so c1 equals 0. We end up with that. Coefficients of x. Coefficient of x on the left is 2c2. There is no coefficient of x on the right, so 2c2 is 0. So c2 is 0. Let's compare coefficients of x squared. Coefficient of x squared on the left is 3c3. Coefficient of x squared on the right is 3c0, which means 3c3 equals c0. 3c0, which means c3 equals c0. And then if you continue this, you'll find that c4 in the same way that we found above. Okay, so you've got 4c4, it's the coefficient of x cubed on the left. 3c1 is the coefficient of x cubed on the right. But we saw that c1 is 0, so 4c4 equals 3c1 equals 0, so that means that c4 is 0. Similarly, from these two, we're going to find that 5c5 is 3c2, but c2 is 0, so c5 is 0. And then we have 6c6 equals 3c3. Those are the coefficients of x to the fifth. Dividing both sides by 6, we get c6 equals half c3. Yeah, c3 was the same thing as c0, so we can write that as half c0. You find that the coefficients, you'll find that the coefficients of x to the 6th and x to the 7th are 0. And so the coefficient of x to the 8th, that's the next one that's not going to be 0. We end up with 9c9 equals 3c6. So if you divide both sides by 9, you end up with c9 equals a third c6. And then let's just express everything in terms of c0 rather than having c3s and c0s and c9s running around. So a c6, as we saw in the last slide, c6 is half of c0. So 1/3 of c6 is 1 over 3 times 2 times c0. Similarly, when you look at the coefficients of x to the 11th, you get 12c2 equals 3c9. Divide both sides by 12, you get c12 equals 1/4 c9. So c9 was 1 over 3 times 2 times c0, so we end up with 1 over 4 times 3 times 2, also known as 1 over 4 factorial times c0. And the trend continues. So this is what our power series is going to look like. You've got c0x to the 0 plus c3x cubed plus c6x to the 6, blah, 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 blah. Because all the other terms are just going to have 0 coefficients. The coefficient of x squared, x to the 4th, x to the 5th, etc. And let's express each of these in terms of c sub 0. So c3 is the same as c0, c6 is c0 over 2, c9 is c0 over 3 times 2, c12 is c0 over 4 factorial. When you factor out the c zeros, you end up with c sub 0 times x sub 0, which is x sub 0 over 0 factorial, plus x cubed, in other words, x cubed over 1 factorial, plus 1 over 2 factorial x to the 6th, 1 over 3 factorial x to the 9th, 1 over 4 factorial x to the 12th, etc. In other words, this series is just c sub 0 times the sum, as n goes from 0 to infinity, of x to the 3n over n factorial. Isn't that cool? I think it's neat.